नेशनल यूनिवर्सिटी का एक प्राउड मोमेंट। डिपार्टमेंट ऑफ अप्लाइड फिजिक्स प्रेजेंट्स इट्स डिस्टिंग्विश्ड लेक्चर सीरीज। आज प्रोफेसर विनोद सिंह वार्मली वेलकम कर रहे हैं और डिस्टिंग्विश्ड गेस्ट प्रोफेसर अशोक कुमार नगावात। Let's begin this inspiring session of knowledge and innovation.
हुआ था, मुझे क्वेश्चन आया।
क्वेश्चन जनरली मैं वैसे ही
लगता है आप एक बुक भी बना सकते हैं।
जी हाँ, जिसमें AI टूल्स में इंफॉर्मेशन क्वेश्चन का
हाँ सर, बहुत जेनेटिक्स को कितना फिलोसॉफिकल अंदाज से पढ़ाते हैं। वही मैंने देखा, वही
Good afternoon, everyone. On behalf of the Department of Applied Physics, Delhi Technological University, it is my privilege to warmly welcome you all to the inaugural session of our distinguished lecture series. This series has been envisioned to invite eminent scholars, leaders, and innovators to share their insights with our academic community, and we are delighted to begin this journey today. We are truly honored to have with us our distinguished speaker, Professor Ashok Kumar Nagawat, Honorable Vice Chancellor of Delhi Skill and Entrepreneurship University, New Delhi, along with our esteemed dignitaries, faculty members, research scholars, and students. To commence the program, I request everyone to kindly rise for the national anthem. Thank you. To mark the beginning of this auspicious occasion, we shall now proceed with the lighting of the lamp, a symbol of knowledge, wisdom, and learning. I request our esteemed dignitaries to kindly come forward for the lamp lighting ceremony.
Ma'am. Yes, sir.
Thank you, everyone. To honor our guest, I request Professor Vinod Singh, Head Department of Applied Physics, to kindly present a floor welcome to Professor Ashok Kumar Nagar.
Good afternoon to all of you. Professor Ashok Kumar Nagawat, Honorable Vice Chancellor, Delhi Skill and Entrepreneurship University. Professor Rinku Sharma, Dean Academic PG, DTU. Dr. Desraj Meena, Coordinator of this program. Respected faculty member and dear students. On behalf of the Department of Applied Physics, I warmly welcome the distinguished speaker, Professor Ashok Kumar Nagawat, Honorable Vice Chancellor, DTU, for the very first lecture, Lecture 1 of distinguished lecture series of the department. I also welcome all the faculty members and students present here. As per the direction of the Honorable Vice Chancellor, DTU, the Department of Applied Physics DTU has started to organize a series of expert lecture, popularly known as the Distinguished Speaker Series, by internationally renowned speakers, distinguished speakers from India and abroad who are working in various academic institutions or research and development organizations or industry or research laboratories. The objective of such expert talks is to create and enhance the research interest among the students and to provide a valuable learning experience to the students of all the programs of the department. We use to collaborate with various agencies. Today's expert talk on reductionism, emergence and convergence by Professor Ashok Kumar Nagawat, Honorable VC DSEU, is the first lecture of the distinguished lecture series organized by the Department of Applied Physics. I am very much happy to have such a great physicist with us to start with this distinguished lecture series. Thank you very much, sir, for accepting our invitation for the very first lecture of this distinguished lecture series organized by the department. Professor Nagawat has very vast experience of nearly 44 years in academic administration, and he is a theoretical physicist and working on various aspects. The DTU has an 84 years of legacy of excellent education and technology, and our department, the Department of Applied Physics, is one of the oldest and leading department of DTU. Our department runs one UG program in the name of the BTech Engineering Physics for PG programs as MSc in Physics with intake of 60, integrated BSc MSc, MTech in Medical Science and Technology, and MTech by Research and Medical Science. The department has recently proposed to start 3 new academic programs in the name of the BTech in Quantum Science and Technology with an intake of 60, MTech program in Quantum Technology, and MTech by Research in the Quantum Technology. And hopefully these new academic programs will be started from the next academic year 2026. The department is a DST supported department. We have received a funding of nearly 1.5 crores funding from the DST under FISC scheme, and currently we have applied for a higher level of level C of nearly 10 crore funding by the DST. Further, the department is an excellent hub for the research. The department has sponsored research project of over 2 crores, funding from various government agencies or other agencies. And in the last 5 years, nearly 550 research publications have been published in various SCI or SCIE journals. 9 patents have been published by the faculty and students of the department in the last 5 years. And the department has 16 academic laboratories, 12 research laboratories, and has very good facility of the research. Further, the department has 25 highly qualified and globally recognized faculty members. And in the last 5 years, the department has produced nearly 80 PhDs. The department is one of the leading departments in the research at DTU. Highest Research Excellence Award. Recently, in the last Research Excellence Award ceremony, 60 of our department, 60 research scholars or researchers from our department won the Research Excellence Award, which is I think one of the highest number among all the departments at DTU. 3 faculty members are either the current or the past former head of the institutions like Honorable Vice Chancellor GBU Noida, Vice Chancellor VSU Nellore, Director CSIR CSIO, Executive Director of NILIC Patna. The department has 3 functional MOUs, one with recently concluded QNU Lab with QNU Lab in order to establish a quantum communication lab at DTU. Other MOUs are with CSIR, CSIO and CCPS, one of the industry. The department is further actively working on the professional advancement of both the students and the faculty, and the department has organized 2 well-known recorded international conference, one in 2019, other one is 2023, and we have received the additional funding of nearly 60 lakhs for these 2 conferences. And as a result of these conferences, we have published the Scopus Index Springer Proceeding in Physics. All the papers are published in these proceedings. And the department has annual departmental newsletter, and our students are getting very good placement. 6 of the students of the BTech Engineering Physics have started their startup, and other students are going for the highest studies in the esteemed universities with good global ranking. I am confident that this talk, this is the first talk of this distinguished lecture series by Professor Ashok Kumar Nagawat, will definitely achieve its objectives, and the whole faculty and students will be benefited by this talk. I am thankful to the Professor Nagawat, faculty members and all students for making this lecture, this event a grand success. Thank you very much. Jai Hind.
Thank you, sir. Moving further, the highlight of today's program is the distinguished lecture series by our eminent speaker, Professor Ashok Kumar Nagawat. Professor Nagawat is an accomplished academic leader, theoretical physicist, and higher education reformer with over 4 decades of teaching, research, and university governance experience. A PhD in theoretical high-energy physics. His research in physics beyond the standard model, cosmology, and computational science has earned international recognition. During his career, he has served as Professor of Physics, Dean of Science, and Head of Department at University of Rajasthan, where he also pioneered interdisciplinary education as the architect of the Center for Converging Technologies, integrating technologies, biotechnology, IT, and cognitive science. He has established flagship centers including the University Innovation Cluster in Biotechnology, Design Innovation Center, and Infonet Center. Beyond Rajasthan University, he has played transformative roles as Director of Skill Education at Rajasthan IIT Skill University, Senior Consultant at Haridev Joshi University of Journalism and Mass Communication, and Coordinator of the Task Force for NEP 2020 implementation in higher education for Government of Rajasthan. At present, he is serving as the Vice Chancellor of Delhi Skill and Entrepreneurship University, where he is campaigning a vision that blends academic excellence with employability, innovation, and entrepreneurship, positioning DSTU as a leader in skill-based learning. We are truly privileged to have Professor Nagawat with us today. And now, with great honor, I invite Professor Ashok Kumar Nagawat to deliver the inaugural lecture of this distinguished series. Please join me in welcoming him with a big round of applause.
Namaskar. I warmly welcome all of you, and it is indeed a great day for me to interact with you in this gathering. I have been here earlier also, and I am fortunate enough that I have been given this opportunity to deliver the first talk in the distinguished lecture series. So at the outset, I thank Professor Pratik Sharma ji, Professor Rinku Sharma ji, and Professor Vinod Singh, and all distinguished professors of DTU to provide me this opportunity. And I am quite sure that the way the test of the history. So wherever it would be written, you would be able to interact with many distinguished scholars and professors in this lecture series. So when it was communicated to me by Professor Vinod Singh, then I had an idea that maybe I would be giving a lecture by using blackboard and chalk or whiteboard and ink pen, and maybe because I like those kinds of lecture only mostly. But indeed, because that kind of facility is not available, and we have amongst you distinguished faculty members of Department of Applied Physics, research scholars, and student pursuing BTech program and master program and undergraduate programs, and many with some exposure of physics. I consider myself as a student of science, technology, engineering and mathematics. Thus formally I am qualified and entitled to the designation of Professor of Physics only, but I do not limit myself in that boundaries. And most of the time, whenever I interact with the student find my lectures different because I have a different inclination. And to look at the issues or questions under consideration from philosophical point of view. So maybe at the end you may conclude that this was not a lecture in physics, but a lecture in philosophy. And people generally have a different opinion about the course on philosophy. Many people don't like to think philosophically. And we are now living in a challenging time where the artificial intelligence would be playing the important role, machine intelligence in our life. And one question was raised that who will eat artificial intelligence? If the artificial intelligence is eating the entire software world, then who would finally should take command over the AI? So there has been great debate in Imperial University on it, and many like me believe that the philosophy will eat artificial intelligence. So I have a presentation, few slides here. I would not be speaking on each and every slide, but this presentation will be available to you, so you can also send me your questions later on also on my email address or on my WhatsApp through Professor Vinod Singh, and I would be happy to reply. So my topic of the talk may sound interesting to you because some of the words which appear here are definitely not taught and not found in the common textbook of the physics. Reductionism, emergence and convergence. But primarily I will be speaking about what was initially called a natural philosophy in 17th and 18th century. Sir Isaac Newton was not a physicist in his own view because the term physicist was not common in his own period. All the publications which Sir Isaac Newton published is in natural philosophies, the Journal of Natural Philosophies, and in Latin language, not in English, because in his time English was not the language of science. The language of science was Latin in the initial centuries of the science. So he published all his papers in Latin and in the natural philosophy. Now we do not call it natural philosophy or natural history. There were two divisions of thought which can be considered as scientific thought, natural philosophy and natural history. We have divided natural philosophy into physics, chemistry and many more branches which you know. And similarly, natural history has now better known as biology, botany, zoology and many branches of life science which were initially thought about as the disciplines of natural history. So whether you like it or not, if you are a student of physics, you are a student of natural philosophy also, or philosophy, because it cannot be pursued without. In my presentation, as I have given the disclaimer, I will be using the ideas and views expressed by many scholars earlier and nothing original. I have learned something and I am just transmitting. So that is primarily the role of a teacher also. So you know that physics tells you that there was a time when there was no time. Or whether this idea is true or not, that is also being questioned in today's time. Whether there was no such time, or time is eternal, or what is time, so we'll come to that during the discussion. But many people who subscribe to Big Bang theory of cosmology do believe that there was no time before time t equal to 0, which is called cosmic time. And before cosmic time, there was no time, no space, no matter, no energy. All of a sudden something happened. What happened in the initial 10 to the power minus 43 seconds, nobody can ever know because of the laws of nature, which you all understand. And so since then, the universe is expanding, everything is changing, the universities are changing, we are changing, and you have witnessed a lot of change in your own lifetime. So my lecture is primarily about this part also, in general, for a human being, how convergence is important for a human being. Because most of the things in learning process we talk about is the change. And change is the common. Every discipline is changing. Whichever topic you like most and which you are trying to study, the views and opinion in that particular area are also changing. Something which was earlier called fundamental may not be fundamental in due course of time. And that is the beauty, and that's why I like science. Because in science, no worldview is final. Every worldview is tentative. Science doesn't talk about final truth. Generally, people don't like philosophy. Why? Because most of the other philosophy, other than the science, which I am talking about, so other than the science, they believe in something. They have final truth. They have final answer. So if you visit a master of Buddhism, a great scholar in Buddhism, then he will have answer to everything. And that is true for all such schools of thought. So there are many schools of thought in philosophy, but with definitive answers. In science, we have learned that answers are always tentative. What is true, what was true in the period of Isaac Newton cannot be true scientifically today, and what is true today would definitely not be scientifically true tomorrow. So it's a great journey when you live with science, and definitely, as I pointed out in earlier lecture here, that most of the young students would be living for 200 years, and you would be enjoying science for maybe 200 years. Life expectancy we expect because of the technological progress to be of that kind, 200 years or more in due course of time. So for a long period of time, you have many things you would be witnessing which would be keep on changing. But there may be something, some aspect, some way, some outlook may be very common. So that is what I wish to highlight in this presentation. So everything has been changing. Now we will keep it stationary here. So when I used to teach in University of Rajasthan, Professor Vinod Singh was also my student. And I have this common habit that every lecture should begin with questions. And should also end with questions. So that is essential in the curriculum if you wish to deliver from a theoretical point of view, that you start with questions. So now, because assuming, so I am not taking you as a scholar or an expert or as a faculty member. So my assumption in this particular presentation, now it is called expert only for experts only, but my assumption is that you have just passed out 12th examination only. And so I am asking you very simple questions, not the tough questions which you would like. So there are 3 simple questions before you, which are related to the physics, you would agree. First one is, what causes free fall of an apple? So that's a very simple question. I have asked this question maybe thousands of times to different people. And how much time it takes to answer this question? Few seconds. Because most of the people don't know the answer. So we, in cognitive domain of learning, the major problem in the learning is that we memorize the things, and therefore we create in the process of memorization of what is called rote learning a mapping between questions and answers. So as soon as the question is asked, we are ready with an answer. And teacher also like those students who give quick answer. But I am a different kind of teacher. I don't like those students who give quick answer. Because quick answers are often laughable. So these are three very simple sounding questions. What is motion? And is energy a scalar quantity or a vector quantity? That is the question. Different kinds of questions I have taken here, maybe not pertaining to a particular topic in the curriculum of physics, but definitely you have encountered all these three questions in the school curriculum of physics, not in DTU. So DTU provide higher level, higher education courses. So what are your answers? So you might zero in your answers in your mind. What are your answers? And if they are different than what the next slide shows, then maybe we can have a discussion. So next slide, the answers are also given. Gravitational force causes free fall of an atom. Next answer is continuous change of position with time constitute motion. For example, orbital motion of the Earth around Sun. And energy is a scalar quantity. So how many of you disagree with these answers? Simple questions and simple answers. We should agree with them. We should have faith in them. We should have belief in them. So, do you have a different answer or the same answers to subscribe? Or maybe you have, at least you would agree that you have done these answers in 12th curriculum, school level curriculum, and you remember, and these are not good, it's very simple questions. These are not, I should not ask in an expert talk. But the next slide, the evaluation is there. Definitely you would say that you should be given 100% based on those answers. Maybe if you are having different answer and not sharing with me, your percentage of score may be different. But suppose you have introduced those answers, then what marks you should get? 100%. Full marks. Nowadays it is a pattern also in the Central Board of Secondary Education that many students score 100% marks in the curriculum evaluation. But my case that your performance is very poor. It lack of understanding of underlying concept of modern physics. So that is what we will discuss. We will keep it here and we will discuss why these answers are wrong. What is wrong in these answers? So if you ask 11, he also says that apple falls because Earth exerts a gravitational force on apple, and that force which is given by mg acting vertically downward towards the center of Earth causes the free fall of an apple, and you can calculate, and you have done that calculation in school, and you can calculate what is called time of flight. So if you drop something from height h, then when it will collide with the Earth's surface, then what time it will take. So that is called time of flight. So if apple is falling, it would hit the ground, and time of flight can be calculated. And then in science, because all of you know that science where anything to survive have to explain the experimental observation should match with the theoretical proposition should match with the experimental observation. So if you measure also the time of flight, then you find that the time of flight experimental observation agrees with the calculations. And you say that it is well established now therefore, because experimental calculation observation is matching with theoretical calculation. This view about the people of an apple should be correct. But the matter of fact is that this view is totally wrong in the modern understanding. And maybe earlier also in this war I have pointed out somebody who was present in that lecture maybe knowing. So I have come here 4 or 5 times I think, and many times, because this is a popular example which I take. So in 1917, and definitely before 1970, because it was published in 1970. So before 1970, Einstein realized that this answer cannot be correct. This answer is a tentative answer, and which in other words means to say that the theory of gravitation given by Newton and the Newtonian mechanics cannot be the correct theory of science. But since students this information is communicated by the school teacher to the student, and one of the major problem in university is that whatever school teacher communicates to the students develop faith in that. And for any graduate teacher or postgraduate teacher, it is a challenging situation. उनका पूरा पक्का विश्वास हो जाता है. This is the correct, this is the final answer. Or otherwise, how could an apple fall? There must be some verification. But you know that if I could come here from Dwarka, so I had to make use of what we call the Google Maps. And you are also using Google Maps. And Google Maps require some kind of understanding to work very well. And maybe you are not aware about the technology because there is a question of technology, how Google Map works. But let us assume that there was no Albert Einstein. Then what would happen? That if I make a move from Dwarka to Dhoni, maybe I would land up in Connaught Place and would search for this wall in Connaught Place if I design the application of the Google Maps by using Newtonian ideas. So in 2017, Einstein came up with a theory which you all know is called general theory of relativity. And it was established that general theory of relativity is different. And there is no word gravitational force in GTR. So if you try to explain the same phenomenon in GTR, the word gravitational force would not appear in the explanation. I am not giving you the explanation which is provided by GTR is that because of the earth, the space-time gets curved. And because of that curvature, the motion occurs and no force is required. In Newtonian view, to change the state of the motion, force is required. And because Newtonian mechanics is based on different concepts and GTR is based on different set of different concepts. So my first message in this expert talk is that something which sounds very good may not be very good. Something which we like to believe may not be the truth. And the only reason of science is to keep questioning. So Einstein questioned the belief of Newton. He was aware about the work done by the Newton. So he had maybe, he may have continued like us in believing the same thing, that there is no need to have any theory of gravitation. But if you study the literature, then you will find why Einstein came to that particular point of view. That is not my topic of the talk today. But it's an important thing that we have to keep changing. In science, you have to keep changing your worldview about the universe. The universe was created long by billions of years ago and it is evolving. And science is also evolving with time. And you have to keep changing. So if you are looking for final answers, maybe you would live for 200 years, but there will be no final answer. Even after 200 years also, if a talk is organized in DTU College, then the same conclusion would be there that we have to keep changing worldview. And something which I would be making here and saying here would be proven absurd and as wrong. So first realization when you learn physics, when you live with physics, when you get engaged in the pursuit of science, is that answers which sounds good may be wrong. So this answer which you have given means as it was mentioned on the slide before. Then the other answers are similar. So is energy a scalar quantity? So is energy a scalar quantity? So how many of you disagree with it? So again in school, first, second chapter maybe you read about unit dimension, scalar vector and the classification is given there that energy is a scalar quantity. So most of the time I have rejected the faculty members, faculty selection when the candidates in the faculty selection for physics department in different bodies and different institutions or different institutions, just on the basis of this question, that is energy a scalar quantity? And the answer would be definitely 99.99% student gave the answer, energy can it be something different? So it's scalar quantity, it can be expressed in certain number of joules, and so it's a scalar quantity. That is another thing which I wish to emphasize here just for making a beginning, that energy is not a scalar quantity. In fact, in your courses, undergraduate courses, etc., you will go through a different kind of formalism. Energy is definitely a scalar quantity in a formalism which we call Galilean. It is a Galilean scale. So if you consider Newtonian mechanics, in Newtonian mechanics, energy is a scalar quantity. But if you consider special theory of relativity, again due to the Albert Einstein, then you find energy is not a scalar quantity. And many of you may have heard of that energy momentum Bohr vector. The name itself indicates that energy is a component of a Bohr vector, and any component of a vector is also called a vector. So energy is not a scalar quantity, but we build our faith. So science, sometimes when we read, it appears to us that it is very easy, because most of those old classical theories of sciences are such that they are very convincing, they are very simple in approach, and we start believing in that. Energy is not a scalar quantity. Energy is a Galilean scalar, definitely. Energy is neither a vector quantity, it is definitely a Lorentzian vector, what they call, because the special theory of relativity is based on set of transformation called Lorentz transformation. So the laws of science or physics should remain invariant under Lorentz transformation from one frame to another frame of reference. That is the concept involved there. But energy is not a vector quantity also. It's a tensor of rank 2, because after scalar and vector, scalar is considered as tensor of rank 0, vector is considered as tensor of rank 1. You may be knowing, some of you, those who have done higher level courses in physics, that there is a classification of physical quantities based on their transformation and their coordinate transformation, scalar, vector, and tensor of rank 2. So if you consider GTR, general theory of relativity, so if I consider Galilean relativity, it is scalar. If I consider special theory of relativity, it is a vector quantity. If I consider the GTR, then it becomes a tensor quantity. So how and we look at anything, so slides are very more, but you have to go back. In a slide it is written maybe here, you should, like, next, forward. So here, next slide. I will, okay, back to the 100% of the score card slide should open. Next slide, tough questions, and then I will tell. So maybe there will be a slide which I have not included, but whatever we view or learn in science is based on a lens. So the entire message so far is that if you change the lens, the worldview would change. If you use the lens of Newtonian theoretical framework, then the answers are different and may be correct to some extent. And if you view it from special theory of relativity lens, then the answers are different. And if you view from general theory of relativity, again different. And in general theory of relativity, final theory of gravitation, then you know that it is not final theory of gravitation. And there are many theories which we have considered under the broad category. And definitely that course would also be taught whenever DTU would be launching a program of quantum technologies and quantum computing, and maybe one of the important field related with the exactive quantum is theory of quantum gravity. GTR is not a quantized theory, and therefore which is the correct quantum theory of gravity is not known till today. But the word is very complex. We would like that the word would have been like what Newton has taught to us, then it would have been much simpler and much better. So nature has its own dynamics, and here the sentence is written that we don't see the world as it is. We see the world through the lens through which we look at it. And then the lens will shape how we interpret the world. And we have to keep on changing the lens. The chashma badalते रहना है. So very fun. Yes.
So then, what would be the right definition of, as you said, the energy is not scalar nor vector, and we say that's a one, energy. Energy is a total energy. So, but
answer.
yeah, so I must have got the right answer. And you said it depends on the interpretation. So we have.
I'm saying, and my entire talk is based on it, and there is no final answer. Point number one. There are three different answers in three framework, and now in this particular talk, towards the end, I will give you a very different meaning of energy, a different interpretation, which you may not have done in any course of BSc, MSc so far, because it is not taught at that level right now. But it is a domain where the scientist and the researcher or physicist start looking at. So what is energy? It's a very tough question. What is matter? Next slide maybe the questions are given which are quite tough questions. There is a slide. So these questions may sound also simple. What is a space? What is time? What is energy? What is matter? What is life? What is consciousness? All these questions are tough, and our answers to these.
Just one question. So when we are asking the energy, so wouldn't we give the full question in the first place? What we are asking, with respect to what reference I am asking about the energy. If I ask in a normal, just we are living in this space, it's normal is correct point.
So you have correctly pointed out, and that is what I have appeared before the High Court in Rajasthan also and stated that there are many entrance examinations for administrative service and teachers and etc. And the questions are asked which are just like the way I have asked the question. So he has rightly pointed out, if I am on the other side, then I would say that this question is wrong. What is energy, or how do you explain free fall of an atom? Unless you specify a theoretical framework, a definitive answer cannot be given. But in most of the time, the question paper which you get, the theoretical framework is not specified. But however, it made our life easy because we divide academic degree programs into courses. And when you go through a course, you know that this is a course of Newtonian mechanics. So your teacher in this school would give you 100% marks that the big wall of an apple is due to gravitational force exerted by the earth on the apple. So that's true. You are rightly pointed out this fact that we are not. So everything is subjected to what is written maybe in the next slide, a theoretical framework, whatever we see. And if you do not specify the theoretical framework, answers cannot be given. So that's the first lesson. The second lesson is that none of the theoretical framework is final. So there are no final answers. So what is energy? It is not known. What is time? It is not known to me. What is the space? It is not known to me. Now these questions are very easy. If you ask it this question, what is time to a layman? He will jump at the answer. So that's it. In one of the recent posts I criticized I raised a particular question, some answers were given and then I criticized. And even if you use AI tools, now you can ask the same question to AI tool, and AI tool will also provide the wrong answer. Because the kind of the algorithm on which the ChatGPT and other AI tools work, and they consider and go through the pre-training program, whatever information has been transmitted to them. The majority of time, the view would be of Newtonian time. So they would generally be, unless you give the prompt correctly. So each and every time you will find that AI tool is giving a wrong answer. So I am a strong advocate that the student of physics, student of science should use AI tools in their learning process. But they should first acquire the prompt engineering skills. How to ask questions. That is what the message which I am communicating here. If you do not ask the questions in correct manner, maybe in the coming period of time, those AI tools would be the sources of learning. For me, the source of learning was the books and the teacher and the courses which I attended and the effort which I made. But for you, maybe now learning has become very easy because now we have these tools. But if you do not have that vision and philosophy, how science should be addressed, each and every time it should be clear to you that whatever I am asking must be related to a theoretical framework. So there is a slide, I think, maybe I don't keep slide in the proper order. Next, that theoretical framework, but here I have written something which is also very important. Now, we know that theory, there are many different theoretical frameworks. In experiments also, what is the great issue related to the experiment? So you can say that that is the problem of theoretician. I am an experimentalist. So can experimentalists know the final answer? Can experiment establish something as a truth in science? That is very important question in philosophy. What science believes about. So in theory, you have already said, and since you are free, you can propose your own theory. And maybe, who knows, maybe 50 years from now, one of these students presented this talk will come up with a new theory, and that theory would give the entire different picture. And my talk can be successful and can be called successful only when this series would be called successful only when you bring some transformational changes, and suppose you probe and you come up with a new answer which is much better. Because I can tell you that now the answers depend upon. But now we have reasons to believe that the answer provided by the general theory of relativity is better for gravitation than the answer provided by Newtonian mechanics. Because the example I have already given, if you design a Google map based on Newtonian theory, it will not work. Google map definitely involve in the algorithm the applications of general theory of relativity, and that is what they call having precise GPS, which you know, because Google map requires GPS. For having precise GPS, the knowledge of general theory of relativity is required. Which means if other scientific development would have taken place and if Newton, Einstein had not given the GTR, we would not be having Google maps. So in Newtonian universe, there cannot be black hole. So behavior, we have now experimental observation, which tells you that there are certain experimental observations which cannot be explained by Newtonian theory. So Newtonian theory is wrong. So what is the limitation of theory? Similar to the theoretical point of view which I said, that theories keep on changing. In experiment also you know that nothing is permanent. The problem is that every experiment has certain limitation, certain precision, certain accuracy, and only up to that experiment. So first what we consider an experiment, we follow up an apple, we measure the time of flight, and we found that the time of flight is actually agreeing with the Newtonian calculation, and so the person would be happy that I have experimentally verified Newtonian ideas. Definitely in that experiment, the kind of the level of the accuracy it is, the verification can be taken and it is taken in the science. But when you do another experiment and you find there are black holes, and then you find that the black holes cannot be explained by Newtonian theory, so you come to know a theory is called final theory only and when it explains all observations in the nature. So because we are primarily concerned with the natural system only, so all observations, all phenomena, all changes, everything which we can observe. But experiment also have limitation. So science with is one part is theory which has limitation, which one philosophically should understand that we have to keep on designing new theories, and because there are issues, there are certain inadequacies. When we move from classical mechanics to quantum mechanics, when we realize that the classical mechanics is inadequate, then one need to learn quantum mechanics also. Our historical development may have a different path. Maybe sometimes we may discover something just by chance, or by it may happen without any reason. So come that Newton also came to this idea of Newtonian mechanics, and maybe he invented the calculus. So all that may have involved a chance factor also. So the second thing, experiment is also a very limited time. So don't be very happy that something you have observed experimentally, because precision of the experiment would increase. So we find, and as you may be knowing, and you will be taught in this courses also, that the GTR effects in the pre-polar apple time of light are not observable, because the kind of the clock which we use in measuring, how precise I can measure the time of light in experiment. So it is not like that the GTR is not applicable in the pre-polar apple, and quantum mechanics is not applicable in the pre-polar apple. But if I measure the time of light, then kind of precision or accuracy which I can achieve is not such where the quantum effects or GTR effect can be discernible, can be experimentally measurable. But wherever I find that experiment is indicating something new, so I have to change my theory. First thing, I have to change my theory because I don't like the philosophy. Maybe I wish to put some questions and I wish to get some answers. The second thing is that there is a comparing the reason, experimental. That experiment is not agreeing with the theory in practice, common theory, then we have to change the idea. So that is it. And the third aspect is the science, because when I started learning science, it was a two-way story, theory and experiment. And my school teacher also explained in science mein yahi hai. You learn theory, you do experiments, and you check or verify. Most of the experimental titles are also like verify Newton's second law of pulling and things like that. So you verify the theoretical conclusions which you obtain from theoretical thing by performing the experiment. So it was a very good story, two-way story, a boy, a girl, husband, wife, father, son. So a kind of love story between the theory and experiment. So science was very beautiful in that respect. So one can have a very romantic view about science. Theory and experiments both wedded to each other. But in due course of time, in my own journey, we realized, and we also know this from stories which we see in cinema and movie also, that people don't like the theories where you have one hero and one heroine. What you definitely need to make a Bollywood film? वहाँ पर भी आप कहते हैं there should be somebody third one, which will sometimes call villain, sometimes a third player should be there. So the stories are mostly triangular. So either hero should fall in love with two heroines or something like that. You have to structurally design. So the very similar situation has happened in the science, that in the beginning and primarily up to the 19th century, mostly it was theory and experiments. And so there were only two paths, and I just asked the Professor Vinod Singh also that there are many faculty members who are pursuing the experiment and a few faculty members pursuing theory. But each of them has something in common. And maybe in modern time, I am not aware about the complete profile of each and every faculty member, but because they are doing something and your department is progressing, so I am quite sure that they are also in love with the third party. And that third party is called now computation. It has become a triangular story. You cannot do theory without computing, and you cannot do experiment without the modern understanding about the universe. So James Webb telescope, maybe you have heard about it. So James Webb telescope provides me the images, and these are experimental images that are obtained by using James Webb telescope. But can I analyze those images? So earlier when I performed the experiment of Newton's ring experiment to establish that light travels like a wave, so maybe whatever I see I can do and make the observation and analyze. Now you all know that the James Webb telescope, we cannot learn anything from the data which it provides, and neither we can learn anything from the data which Large Hadron Collider experiment provide. because the kind of the data or information size is so huge that we need to have computing resources. So it has become a three triangular story. Theoretician is also talking to computing and computation, and experiment, because experimentalist has just not to record, it has to come with the interpretation. So we will also need to talk with the computation. So the story has become very interesting in 20th and 21st century. And most of them therefore must realize that the world of computation is also changing. And there are questions there also. In the experiment, our aim is to improve the precision and efficiency of the experiment. In theory, our aim is to come up with a final theory which can explain all experimental observations. But computation is still in infant state because it has picked up in the last century, only 20th century. Most of the computing ideas which are more important and relevant today. So, if you wish to make a new material which can change the world, what you would require? So that kind of thought is very important in personal physics research in modern time. So what kind of theory? Can I make a beginning by using theory first, then experiment? Or theory, then computation, then experiment? That is what we talk about in the top research world, and that is what I wish to provide. But before coming to that, I would now emphasize another aspect, because all the aspects which I will be presenting finally will give you one picture, and that is how we proceeded philosophically in our learning of physical systems. Because at least you may not be interested in biological system. So physical system. Biological systems are more challenging, more interesting. But generally the physics students have less liking for biology questions. And few days back I posted a question also, why organisms are called organisms? Because they are made of organic molecules, or because they are made of organs. So now it is a very simple sounding question. Why organisms? Like we are also organisms, and we have microorganisms also, bacteria. So why organisms are called organisms? So this is a different kind of question which I don't wish to, but you can probe rather. Because an organism is something which has organs, or an organism is made of organic molecules. So the researchers in the biology could not answer the question rightly. And again, because of the same reason, like you have not answered the pre-work questions rightly. The researchers in the biology believe that organisms are called organisms because they are made of organic molecules. And that is the wrong answer. In fact, again, now why this is the wrong answer, you will have to drop on your own, because I will not provide all the answers here. I am not here, I am just here to cultivate the religion, attract you towards my religion, and that is the religion of science of question. Keep questioning, keep changing, not being happy with anything. But still you have to keep your peace and comfort. Now what is the reductionist approach? So if you know that when you have learned the theory of Newtonian mechanics, again very simple theory, the first few chapters you got dynamics of rigid body. Now how you understand dynamics of a rigid body? So in the school curriculum, so we say a body consists of particles. And we understand it in terms of particles, because all the Newtonian mechanics, primarily the laws of Newtonian mechanics are for particle. And particle is a hypothetical system. Nothing like particle exists in the nature. Because particle in Newtonian mechanics, I am saying just again word, particle in Newtonian mechanics, like energy, Galilean relativity. Particle in Newtonian mechanics is a point size structureless object with physical characteristics. That is the definition of Newtonian particle, wet vesicles. Point size. Point size is an infinitesimal size, zero size. There is nothing which is of point size. You cannot find an object in experiment, so you cannot perform any experiment on Newtonian particle. But you feel happy that Newtonian dynamics is very useful because a body can be divided into particles, and in rigid body you further make a restriction that the distance between the particles which are constituent of the body is not changing during the course of motion. So that is what the meaning of rigid body in Newtonian mechanics. And so the dynamics of rigid body, the approach is that dynamics of rigid body is divided into dynamics of particle, resolved in terms of dynamics of particle. This approach is called reductionism. Any scientific theory or any scientific study is a systematic study of a natural system. And every system possesses certain characteristics which you can divide into different types, and some characteristics can be measured, so we call them quantities. So in physical systems there are physical characteristics, and some of the physical characteristics can be measured in experiment, so these are called physical quantities. So we do things like reductionism, that divide and rule is not only a political thinking. Divide and rule or understand, I will not say rule, divide and understand has been a practice very common in the world of physics and scientific studies. We divide system into subsystems. Even if you study biology, for some time what you would be studying, you would be dividing, now you know, human body which is made of several organs. So you would divide body into organs, and you would say that the blood pressure, because primarily the organ which is responsible for controlling the blood pressure may be the heart, that pictures and so people have, and so they will focus on it. Maybe we don't know the final answer there also. Maybe brain has some critical role in controlling blood pressure. So scientists, researchers, they are also questioning this idea. But whether you consider biology, whether you consider chemistry, whether you consider physics, this was the common beginning, and that was called the beginning. We had this idea that a system can be divided into subsystems, and we can understand a system in terms of subsystem. Now this is in philosophy called the philosophy of reductionism, reducing one system into another simpler system. The particle is a very simpler system to handle in Newtonian dynamics in that particular case. So whether this approach is right or wrong, that's a question here which we are talking about. In reductionist approach, this is justified with the very beginning. In philosophy, when it was expressed, this question was expressed that when this approach would be successful, if you divide something into two parts, and if you combine the two parts, they should again become the same thing. So sum of parts must be equal to whole. That is an equation coined by a great philosopher. The sum of parts, the whole can be divided into parts. So we had this particular approach, the whole can be divided into parts. And if we understand the part, we can understand whole. Because understanding the whole is nothing, but understanding the parts. That is what we are also doing in the entire process of learning in universities and institutions. What we are doing, we are dividing the academics into different disciplines. And if you understand each one, so we believe that all disciplines taken together, maybe we will have the complete understanding. So that is the approach of reductionism. Now, whether it works or not, so that is very important. What can be the alternative thing? So alternative thing is that the sum of part is not equal to whole. क्योंकि दो ही relationship होता है. If you consider the relationship, mathematical relationship of equal to, either it is equal to, either you are equal to me or you are not equal to me. So that kind of algebra relationship is there in mathematics. So only two choices. So either sum of part is equal to whole or sum of part is not equal to whole. Which you जिससे बनी हुई है तो वही उसमें रिफ्लेक्ट, तो it is also useful in society. That what is society? A society is made of what? तो members of the society. तो आप किसी भी समाज के सदस्य हैं तो समाज सदस्यों से मिलते हैं. तो किसी ने प्रपोजिशन दिया कि the behavior of a society should be the sum of the behaviors of the individuals in the society, individual members of the society. तो जैसे individual members का behavior को add कर दें तो society का behavior आना चाहिए. Most of the sociological theories are also based on this philosophy of reductionism, the word which is and my topic of the talk. So now whether it is correct or not, so that is a big thing which we don't know. Maybe it is correct in some respect, maybe it is wrong in another aspect. But what is the alternative scenario? Say in sociology, if the society is not the sum of the individuals, then what it is? So it may have certain behaviors, social behaviors, society behavior, which is different than the sum of parts approach, which means sum of part is not equal to what. This particular thing, when realized, then a new kind of philosophy emerged, and that is called the philosophy of emergence. That sum of part is not equal to what. The great philosopher, come scientist, come physicist, Phillips Anderson has said, and उनका जो नारा है वो है more is different. You may not have heard of this nara in physics books, but this should be definitely taught. That's why I am giving this lecture. That more is different. More is different means that the sum of whole is different than the sum of parts. This approach cannot be so. When we talk about fundamental constituents of universe, so we can continue with this approach of reductionism. What I will do, I will divide materials into molecules, molecules into atoms, and when I learned that there are only 118 atoms, different kinds of atom, I become very happy that if you understand 118 atoms, you understand all the materials. Because every material is made of atoms. But that is very wrong thing. By understanding 118 atoms, you cannot understand all possible materials which can be made. Some of you may be pursuing the research in material science. So how many materials we can make and how much we have made, then our performance will be much worse than my previous question performance. What we could achieve so far is very, very little. That is the realization. Because how many atoms are there in the universe, and by using those atoms, how many possibilities are there of creating different configurations of the atom. So that you can ponder about after my lecture is over. And so it is told that maybe we consider iron and atom as same neutral atom or atom in molecule as an atom. We treat all the three things as an atom. Then maybe there are 10 raised to power 80 atoms in the world, universe. And out of 10 raised to power 80 atoms, how many materials and what possibilities are there? That's a big question. And that question is related to the question of emergence. That what is possible? So people do realize that now we continue to believe in reductionism. I am not here to advocate reductionism. Generally, theoretical high-energy physicists like me are strong advocate of reductionism, because theoretical high-energy physics is done in this manner, that everything is made of quarks and leptons shown here, and there are 4 fundamental interactions. And the reductionist approach tells me what? That if the price of banana increases tomorrow, I should be able to extend it using standard model of high-energy physics, because what we are, everything which plays role in the price of banana is a physical system. A human being is a physical system, a banana is a physical system. Everything which you do in economics is being executed by the physical system. So we say that physics is the fundamental science, and everything is, since every system which you perceive in universe, in the environment around you, is physical. So reductionist approach tells you that you can explain the price variation in banana in terms of this model, standard model of high energy physics. But actually we find that it is not possible. Nobody, never you have read that what is happening and what a part is playing. However, everything which is involved in the process, so maybe pricing has something to do with the brain. The owner decides something and so has something to do with the brain. But in the brain also a neuron. And neuron are also made of atoms. And generally a neuron has certain number of atoms, few hundreds of atoms. Each neuron which we say, now there are billions of neurons in our human brain and it's a very complex subject, complexity there. So definitely if we can reduce a complex system by reductionism into simple system, the life would be easy. That would be Newtonian like life, considering dynamics of body in terms of dynamics of body. But it is not true. Emergence tells you that you cannot explain sometimes. Maybe there are two different kind of emergence view. One is called anti-reductionism, that reductionism is absurd. And another is called that there may be reductionism approach, but it is practically not possible. And the properties arise because of something, so are emerge. So what does it mean? I will just explain so that at least you can know after my lecture the meaning of the emergence. Now consider, you are familiar and you have studied and you know this particular material called water. Water के बारे में आपको जानकारी है? No. Water is it? So water exists in solid, liquid, gas phase. ये सब आप जानते हैं. And you also know that water is made of water molecules. Water system you call it made of water molecule. Now what is water molecule? Composition. If you reduce the water molecule, then in school you have been told that it is H2O. And now what is H2O? H2O means 2 hydrogen atom, 1 oxygen atom. Now the question, if reductionism is right, then the question is, can I explain the property of water molecules in terms of properties of hydrogen and oxygen atom? तो अब आप केमिस्ट्री की किताब खोलिए, उसमें प्रॉपर्टीज ऑफ वाटर देखिए और प्रॉपर्टीज ऑफ हाइड्रोजन देखिए, प्रॉपर्टीज ऑफ ऑक्सीजन भी मिलेगी उसी केमिस्ट्री की किताब में. And if you can explain the properties of water molecule based on the properties of hydrogen and properties of oxygen, then you will be happy. Okay, this reductionism is working. I can understand water in terms of its constituent. But you can very easily understand it now because the kind of the knowledge and training which you have been given, that the properties of H2 cannot be explained. At least we don't know at present the explanation in terms of the properties of hydrogen and oxygen atoms, and which means these properties which we are measuring are the emergent properties. These are not explainable in terms of reductionism. So any properties which arise because of the emergence is called emergent property. So what are emergent properties of water? So one example, one emergent property of the water is wetness. आप कहते हैं ना पानी का अभी मैंने हाथ डाला इसमें तो गिरा हुआ है. हाँ, ये wetness it is defined which you understand. The water makes a surface wet. Now, does hydrogen possess that property? Hydrogen किसी को wet करती है. Does oxygen possess that property? Water, you believe, I am not saying that water has this property, but you believe that water has this particular property which we call wetness. Now, I asked this question to Vinod Singh one day and he could not answer. And that question is whether a single molecule of water will be wet or not. Single molecule. What I am having, how many molecules are there? Now you can calculate. Because you have been told that in 18 gram of water, Avogadro number of molecules will be there because that is the theory which you know and which you have done in school. So there are large number of molecules because it is more than 18 gram. So more than nobody can count it, but large number. But is so wetness carry any meaning for a single molecule of water or not? There cannot even be exact forget about, and we may say that if you go from molecule to atom, reductionism fails. But suppose I just keep the collections of water molecule, then does it work? So if water makes something wet, then single molecule of water should also make it wet. But again, you can do the experiment, because now these would require doing any experiments at single molecular level. You have to think how to do and verify. But you find in literature, if you ask the AI tool, that whether a single molecule of water will make a surface wet or not, so AI will tell you no. Wetness, there is no wetness by a single molecule. How wetness is defined? It is defined as an emergent property. So we find that the behavior is different at different scales, and at different scales the emergent properties may be, and that's why the people believe that now we are also made of quarks and leptons. Life is an emergent phenomenon. If you fall in love with somebody, it is an emergent phenomenon. Consciousness is an emergent phenomenon, and it's not fundamental, which means it cannot be explained in terms of the fundamental constituents. So now emergence may be another picture which I have shown you. I am not even aware of what slides are there. That what appears to you, this table appears to you flat, and you think that it is continuous. Now, what we mean by continuous? By continuous we mean there should be no gap. Everything should be smooth. So that is the meaning of continuous. But has you ever observed anything which is continuous? In theoretical world also, the continuity is not well understood. This is a big question in mathematics. What you call real numbers are continuous. Continuity of real number is called point-like continuity. And when you study the real numbers, which you must have done in school course of algebra, then you find that between two rational numbers there are infinite irrational number, and between two irrational number there are infinite rational number. What kind of continuity? How can you picture it? This is not something continuous which a layman has a meaning of continuity. Everything smooth, no gap at all. But in Kanaki, between two irrational numbers there are infinite irrational numbers. So this continuity cannot be of that type. So continuity has a mathematical meaning. When we use in physics, we use the meaning of generally from the real calculus. So the real point-like continuity. And here it's not that table precise. But what you find that the surface, when you look from a microscope, doesn't appear to be continuous. So that's a emergence thing, that it is continuous at larger scale, it appears at smaller scale. Now this question of emergence is very important because the properties may be different. There are many examples of emergence can be given. Maybe I may have included in the slide also. One popular example is that how you study gases, behavior of gases. So you must have learned about kinetic theory of gas. A gas consists of molecules, and then you try to explain the behavior of that system in terms of molecules, and you arrive at the formula and the equation PV equal to mu RT can be derived. And we understand that the gas behavior can be explained by reductionist approach in terms of the molecules. That is the entire approach of the kinetic theory of gases. But at the single molecule level, a molecular gas may not behave in the same manner like the bulk gas which you have in a thermodynamic system behaves. That is what I realize, and I often give an example. That what is the color of gold? बहुत सारे लोगों ने पहन रखे हैं gold ornaments. तो आप बता सकते हैं what is the color of gold? Color is a property, and color of gold.
Yellow metallic.
The color of gold is the question. Answer भी पहले से मैंने बताया of gold is golden. तो हम कहते हैं gold से हमें नाम दे दिया जाता है कि जो भी gold का कलर होता है that is called golden color. Somebody may say it's yellow, but people do not like yellow. That sounds very easy, simple sounding. So we call color of gold is golden. So if you have bulb, अंगूठी है आपके पास कोई, तो उसका कलर गोल्डन आपको नजर आता है. Color is an emergent property of the system which you are having, that when light or electromagnetic waves fall on it, how it interacts with. You will study in different parts of curriculum जहाँ पर भी आए. But now you can understand emergence in this manner also. That if you keep on dividing the gold, तो आपने 1 ग्राम गोल्ड लिया, फिर आधा ग्राम कर दिया, फिर आधा ग्राम को और आधा कर दिया. If you keep on dividing, whether it would remain golden in color. So now people do know that gold nanoparticles have different color. Blue, red, or even green color gold is also. And earlier also some people in history, people could make those colors out of the gold and have been used in the paintings, and such paintings, pictures are available on web also, where you can find that gold is used in painting, but different colors have been obtained from the gold by just grinding the gold so fine. So if gold, as pointed out by the madam, as a nanoparticle, is a different emergence, and emergence of even more is different, then lot of prospects are there. This is a very simplistic view which I am. Okay, when more is sum of parts, then learning becomes very limited. But the entire universe and our life is very, very complex. Since more is different, so lot of probabilities, lot of prospects are there, lot of things. So now the question is that what is the convergence? So we find that if we wish to consider the scale, then Feynman made a statement, and which is the statement of convergence in my understanding. And he made this statement in 1959. And the statement he made was, there is plenty of room at bottom. It is the title of the talk, but I will just emphasize the statement. So what is the meaning of there is plenty of room at the bottom? There is plenty of room at the bottom, he said, and because there is plenty of room at the bottom, in future it would be possible to write the entire Encyclopedia Britannica on a head of a small pin. This is in his talk in 29 December 1959, in American Physical Society conference here. So what is the meaning of that? So that we have realized there is plenty of room at bottom. He realized that diamond has certain properties, and graphite has certain properties which you have read in chemistry and physical chemistry books, physical properties as well as chemical properties of diamond and graphite. And then you find that the physical properties of, like, refractive index of diamond is very high, and the graphite is black in color, diamond is shiny. So the optical properties are quite different. But both diamond and graphite are made of carbon atoms. Had reductionism be true, तो ये लगना चाहिए तो एक लेवल पर तो कि there is a view that reductionism can also explain it, but otherwise it would appear that the behavior of diamond and graphite should be very similar. Had configuration is not important, but because of different configuration which we understand in chemistry curriculum, sp3, sp2 hybridization, there is a technical terminology available. The diamond and graphite are made of carbon atoms. Then how many such forms can be made of carbon atoms? That was the question before Feynman. As a theoretician, he was not an experimentalist, so he was a theoretician. So he asked himself this question: how many allotropes of carbon can be there or can be made? And he brought each and every theory of the science and physics known at his time, and then he came to the conclusion that there is no law of physics which is known and established as mentioned here. This is also of the article which you can find. So the diamond and graphite, many more such carbon atom arrangement can be made, he realized, because no rule restricts the how many. So he said, since no rule restricts, whether quantum field theory, whether uncertainty principle, all kinds of theoretical ideas which were in existence at that time. He explored and he came to the conclusion there is plenty of room at bottom, and in future people will be making molecules at atomic scale, and that is the nano scale. And the term molecular manufacturing maybe in a slide was coined, and the molecular manufacturing term highlighted that you can make materials, new materials at molecular scale, but molecular manufacturing did not become popular term. Why it did not become? Because people don't like it. It sounds very simple. So when people in 1990s, I made a statement that India has a great potential to become the hub of e-babus. It was a term coined. India has the capacity and it can provide services to the world. E-babus, providing clerical services to the world. But people don't like the term e-babus. You know, there are many. E-adjective is the most popular adjective. But e-babu has never become popular because people don't like it. So the babu word is there. And they glorified it by calling it business process outsourcing. Call center business, service outsourcing. So two popular words. So similarly, molecular manufacturing, that you can make new kinds of materials by working at nano scale, is now known as nanotechnology. Because this nanotechnology sounds more appealing, more good, more attractive. And what nanotechnology is happening, that maybe the dynamics of the nature at a particular scale is seen. Nanotechnology is not only important for making new materials. We as the biological species are made of biological material, and one of the important biological material, as you all know, is DNA and RNA. And in DNA, you know that there is what we call gene. And if you just change one of the atoms' orientation, the gene will get modified. The gene is based on what? Configuration of atoms. So it is just like that if I can make new configurations of carbon, which may be shown in the next slide, buckyball and fluorine, and those we can manufacture after the Feynman's prediction. That new kinds of materials can be made from carbon, and now you know the carbon nanotube and graphenes are the most popular material. Many of you may be knowing the physics. And we also have quantum field theory of graphene also, and we understand it from quantum mechanical point of view, from reductionist approach also. But it has opened us our mind. So, lot of scope is there because any DNA manipulation will be nanotechnological manipulation. If you try to understand brain science, neuroscience, so definitely the neuron, one neuron is almost consists of few hundred atoms. So everything, if we later want to control and change and revolutionize the thinking of human brain, then that would also involve nanotechnological manipulation. And similarly in computational science also, the kind of the semiconductors which would be used now, and we are now moving in a much different direction of quantum computing and quantum, which I will not talk about it here. But he realized that NBIC, nanotechnology, biotechnology, information technology and cognitive neuroscience are converging into each other. And which means that now we should do away with the reductionist policy in this manner also, that we cannot divide disciplines as physics, chemistry and biology as we have done. If you wish to pursue something, a research in neuroscience, brain science, or about life, or if you wish to answer the question what is consciousness, you will have to go through the literature of physics also, philosophy also, mathematics also, all related disciplines. That is the message which I wish to communicate to you in this. Convergence is there. If we divide, but still we divide and we understand emergence, but emergent phenomena are also converging. Now something which I am not covering because time is limited already. I have crossed the limit of the time. I don't never care about it, but since time is limited, in a better discussion, if Professor Vinod Singh invite me again, we will continue the discussion because lot can be said. Maybe I can speak for 6 hours on it, and a discussion can also be had. But what is the message which I wish to give you is related to that. This convergence idea should also be applied in all different aspects. Number one, and that is that earlier we used to think that biological species are intelligent, and among the biological species, human beings are most intelligent, and therefore human beings have all right and all powers to utilize all the resources on this planet Earth and do whatever they want. तो हमने सारी कोशिश हम उसी ढंग से करते हैं कि हम महान हैं और बाकी सब जीव तुच्छ हैं हमारे सामने। तो हमारा आचरण ऐसा ही रहा है और हमने प्रतिक्रिया भी किया है। Now people are questioning whether it is sustainable, life होगा या नहीं होगा and so on and so forth. So that's what the question. But intelligence, as you now know, is no longer our right. And very soon, as Ray Kujwal has pointed out, and as many scholars in DTU may be working, that the machine intelligence will surpass human intelligence. So, what is the message based on reductionism, emergence and convergence in that case? So, if machine intelligence surpasses human intelligence, so we can learn, Radhika Mahatma is saying, from biological species which have legal intelligence, like termite. Termite का साइज आपने देखा होगा, दीमक कभी घर में लगी होगी तो कितनी छोटी होती है, तो आपके साइज के हिसाब से आप कितने भी स्लिम ट्रिम हो, लेकिन आपकी साइज के कंपैरिजन में इट इज वेरी स्लिम ट्रिम termite. And termite never attends a school or engineering course at any institute. But termites can come up with a beautiful structure, architectural structures. You आप images देख सकते हैं, बयार है, घोंसला बना सकते हैं. And intelligence of individual termite, individual is very less. But in case of termite, the what is manifesting in their creation or their contribution is the collective intelligence. Convergence of intelligence plus kinship. There are two kinds of intelligence right now, and we should talk about it. One is called human intelligence, another is machine intelligence. And we are living in an era where a transition would take place. So what should be our approach? To suppose machine intelligence surpasses the human intelligence, what we should do? So I asked this question to my student. This in a different form. And question was कि अगर आपके मोहल्ले में कोई ताकतवर व्यक्ति आके रहने लग जाए, बहुत बलशाली प्रभावशाली व्यक्ति हो जिसकी चलती हो, तो आप क्या करें? What would be your action? If in your neighborhood somebody very powerful, influential, dominating person comes and starts living, there can be two options. Option number one, आप उससे जाके पहले दिन से झगड़ा शुरू कर दें कि इस मोहल्ले का मैं ही शेर हूँ और मैं ही रहूँगा. You can fight with it. So many people are thinking like that also. That one way to handle the situation is to fight with it. And what is the other option? Can you think of any other option? Suppose you don't believe in fights. Now, friendship. So as he pointed out, कि आप इसको दोस्त बनाएं. When you make it a friend, then आप जानते हैं कि बहुत सारी आपकी जो पावर है वो आपके दोस्तों की पावर. कई बार दोस्तों से शक्ति मिलती है. तो because जैसे मैंने कहा कि more is different. तो आपके दोस्त होंगे तो आप दोनों से भी ज़्यादा होंगे. दो लोग भी हैं दोस्तों, वो दो से अधिक होंगे because more is different. कहती है. And so friendship करें. और यहाँ पर मैसेज क्या है? यहाँ मैसेज ये कि you have your own intelligence, but now an intelligence which is maybe much superior to you is coming in existence. So the only option left with you is that you follow the path of augmented intelligence. तो आज का जो मैसेज है फाइनल है for faculty, for student, that जो मैं हर एक जगह कहता हूँ आजकल यही मैसेज देता हूँ तो आपको भी दे रहा हूँ. And that message is that augmenting our intelligence using machine intelligence is very, very essential. We have to leave away our own biases. We should have a common thinking, of all disciplines, but at the same time augmenting is essential. उसमें क्या किया गया? तो अभी नवरात्रि चल रही है, तो मैंने उसी के आधार पर एक कंसेप्ट दिया कि every day, every student, every human being, every intelligent person, every faculty member should interact with AI tools for 1 hour just to augment the intelligence, not for the fun. Ask funny questions, any funny questions, even the AI has that capability. Your teacher may not sometimes. Like kind of the questions that I have asked, the embarrassing questions teacher do not like. Because they want to focus on the curriculum. कैसे बात करेंगे, क्वेश्चन पूछेंगे तो कोर्स कब कवर होगा. The teacher can criticize. Teacher has much more power to derail you. But you, आपको ये मालूम होगा कि चैट जीपीटी कभी गुस्सा नहीं करती. उतना भी funny question भी पूछ ले, it would try to understand your question and try to give some response to you. And you can learn any questions related. This is the question, what is the difference between reductionism, where reductionism fails, where emergence succeeds, where it fails, what kind of emergent properties are there, whether life is an emergent property or not. All these questions you cannot ask to your teachers here, but you can ask to ChatGPT. And you can augment your intelligence by using the intelligence of the machine. That's an opportunity for you for survival. If you don't do that, you would not be able to survive in coming period of time. And I have already reminded you, you will have to live for 200 years. तो या तो आप मोहल्ले में कोने में पड़े रहेंगे, अगर मोहल्ले में सही ढंग से रहना है, तो मोहल्ले का नया नियम यही है, augment the intelligence. तो मेरा आपको मैसेज है कि augment your intelligence with the machine intelligence for 1 hour daily. तो जिस दिन आप रिकॉर्ड रहे, क्योंकि आप मोबाइल फोन का इस्तेमाल करते हैं, AI टूल आपको एक्सेसिबल है, but you keep the record. If you have not used the AI tools for augmenting your intelligence for 1 hour, उस दिन व्रत रखें. नवरात्रि पे व्रत रखना जरूरी नहीं है. उस दिन भी व्रत रखें, खाना नहीं खाएं, तो अपने आप आपको 2-3 दिन बाद पता चलेगा कि आज तो 1 घंटे पढ़ना ही पड़ेगा, क्योंकि तो ये मैं सौगंध इसको कहते हैं, कसम ये दिलाने के लिए स्टॉप पर हूँ कि every student present here, every faculty member present here, every intelligent being, every human being who cares about the survival of the human being has now in this modern time the duty to augment his intelligence. And the next is that we have to learn, like from Karmai, the art of collective intelligence. Emergence and convergence all emphasizes that, unless we understand. And last thing, which is for further study, next topic our होगी. तो जैसे इन्होंने कहा कि एनर्जी और मैटर, तो अभी लोग ये मान के चलते हैं कि यूनिवर्स के फंडामेंटल कंस्टिट्यूएंट क्या है? एनर्जी और मैटर, जो स्लाइड में क्या है. नाउ राइट डाउन द नेम ऑफ द physicist who is also a medical doctor, also MD and as well as MSc physics, and very great person, great scientist of present time. उनका नाम लिख लीजिए, अनीता गोयल, Indian origin, living in United States. Now what Anita Goyal is saying, so you will have to pay attention to that. And maybe, so what other scientists are saying. So people are saying maybe information, matter and energy are fundamental constituent of nature. Information is not mathematical and abstract. So few people are saying that. Then there are scientists who are saying matter is not fundamental at all. It is an emergent phenomenon. Space and time are not fundamental at all. It is an emergent phenomenon. Space, time are emergent phenomena in a theory which is called loop quantum gravity. मैं आपको वर्ड्स में से बता रहा हूँ ताकि आगे आप समझें. So anything which you believe which is fundamental is really being brought by the scientists at the top level as not fundamental but an emergent. And this kind of emergence would keep on happening. तो हम कह रहे हैं कि हम कोई fundamental नहीं है. Consciousness may be the fundamental constituent of the universe. So many philosophers, many scientists now subscribing to those type of views. तो मेरा काम जो यहाँ पर बुला करके गलती किया उन्होंने अच्छा किया, तो मेरा काम ये था कि जो स्टैंडर्ड वे ऑफ फिजिक्स डिपार्टमेंट के फंक्शनिंग को है जहाँ भी मैं जाता हूँ, मेरे नाम में लगावत है, मैं लगावत फैलाता हूँ, लेकिन उसको डिस्टर्ब करें. You can learn and master your curriculum But mastering the curriculum is not the objective. Giving new ideas, shaping the world, setting the future, ensuring the better future for mankind, ensuring the better understanding of the nature, that is the idea, not the curriculum. Curriculum is just a mean. And now you have this power of moving away from the curriculum and start learning, because now your learning cannot be limited by the DTU, because DTU cannot issue order to change GPT. इसको खुद पर बताना इस कोर्स के बाद. So that kind of picture is not there. So for that message, and just to explain, a lot of things are there. I had to summarize and ignore many things in making this presentation, because my idea was not to inform you about something, but to coin something before you so that you can later explore and learn on your own. So none of the most of the things are not answered. Maybe one of you would answer what is energy actually, and whether energy is fundamental or energy is an emergent phenomenon, and whether energy is a tensor of 2 or 3 or 5, or whether energy makes a definition only in 10-dimensional space and 5-dimensional time. Because now people are saying time can be 2-dimensional, time can be 3-dimensional. So all these questions sound funny, but are being probed by the physicists, by the researchers all over the world. Nothing from my side. Okay? I am not doing that kind of prominent research, I am not contributing, but I am aware about it, and so to spread that awareness further, so that people from India, the students from India, can also contribute in later on in improving our understanding, because we are students of understanding, problem solving, and that's the prime our purpose on being there. So if life has any purpose, that is the prime purpose which one does. Now physics and science as have been developed, it is believed that there is no purpose of the universe, but we are trying to make out a purpose for the universe, or at least the dynamics which is around us. Thank you for kind and patient hearing.
कैमरा उठा लोगे वो?
Thank you very much, sir, for your enlightening and inspiring lecture. To honor his presence, I request the dignitaries to kindly proceed with the felicitation of Professor Nagawat with a token of respect. Now I invite Dr. Deshaj Meena to deliver the vote of thanks to our to the speaker of this lecture.
Thank you. Good evening, everyone. Respected Professor Ashok Kumar Nagaur sir, Honorable Vice Chancellor, Delhi Skill and Entrepreneurship University, DSU, Government of NCT Delhi, Professor Vinod Singh, Head of our department, the faculty members of the department and university, research scholars, and dear participants. It is an esteemed opportunity for me to propose a vote of thanks on the occasion of this maiden lecture of the departmental lecture series of the Department of Applied Physics. First of all, I am highly thankful to Professor Ashok Nagaur sir, Honorable Vice Chancellor of DSU, who has accepted our invitation as an expert speaker for our departmental distinguished lecture series. Sir, thank you so much for taking out time from your busy schedule to deliver this wonderful and very insightful lecture on the topic of reductionism, emergence and convergence. I am very much sure that our participants and students have taken a source of inspiration from your lecture, and your words are a great source of encouragement to all of us. You made this lecture very interesting by asking the simple questions and then answering their questions in different frame of reference. So it is a very interesting lecture and very beneficial for all of us. So thank you so much, sir. Further, I would like to convey my heartfelt thanks to Professor Prateek Sharma, Honorable Vice Chancellor of DTU, for his encouragement, inspiration and motivation to organize this distinguished lecture series in the department. We are also thankful to Professor Narendra Kumar, Registrar DTU, for all his cooperation for the smooth conduction of this event or this lecture. We are extremely grateful to our Head of the Department, Professor Vinod Singh, for inspiring, guiding us towards the smooth conduction of this lecture. Sir, your continuous support and advice have greatly helped towards the successful organization of this lecture. Further, we are also thankful to Professor Anil Haridas, CPO, DTU and GA branch DTU for helping us in providing the required logistic support. And I must not forget to thank the volunteers and the students team who have contributed and worked very hard to organize this lecture of the department lecture series. So I thank my volunteers and the team who worked very hard to conduct this or to make this event successful. I once again thanks everyone whose contribution has made this first lecture of the departmental lecture series as a successful event. Thank you all.
With this, we conclude the inaugural lecture of our distinguished lecture series. I request everyone to kindly join for a group photograph.
Thank you.